thing I'm going to do today is go over the gist of the syllabus. It's pretty similar to what you've seen in the past. Okay, so you should be looking at our class's Canvas page. Agree? Right, perfect. So I'm going to go over to the syllabus one because most of what I want to talk to is there. Maybe make it a little bit bigger. I don't know if that helps, hinders the process. There we go. You all know to contact me by email. Don't use WebAssign, ask your professor, or ask for extension. I just never get to see those damn things, right? So that's pretty straightforward. Prerequisites, well, if you're in the class, it's already been checked. If you're in the wait list, you just need to talk to me, prove it. If you need to get some technology, because maybe the stuff you've got died on you over the holidays, you can borrow, get a loaner off the college. There's a link. Since we're using WebAssign, here is our class key. I think about 8 of you are already joined, so that's good. The rest of you should get joined as soon as you can. Here are various dates. You can go and look at this in your own time. I guess the important ones to talk about right now is that Monday the 17th is a holiday and Monday the 21st February is a holiday. And so there won't be classes those days. A little bit different, or a lot different. There's going to be a midterm and there's going to be a final, which isn't different, but the midterm for sure. And this is a little bit different as well. Your homework's pretty much the way it always would be. So for instance, this week, we are going to do 11.1, which is sequences, and 11.2 is series. And really for the newbies, but it doesn't take long, 15 minutes for the rest of you, getting started in WebAssign. Now, what is different is that there's going to be online tests at the end of each week. So things are in weekly format now. What will an online test look like? It'll look just like homework, but with one major difference, or a couple of major differences. You won't see it until Saturday morning, and you've got until Sunday to do it. And second thing that's more important is that it's timed. So when you click on it, you better be ready to do it because you've got 90 minutes and then it'll cut you off. But this does not require you to show me working or, anything else. You just do it like you would do a normal homework question. It'll be very similar looking. And it will only be on that week's work. So test 1 will only be on these 2 sections. Test 2 will be on these 3 sections and so on, right? So that's a little bit different from last time. And there's all the classes, and I'll talk. Well, actually, let's talk about it right now. Calc 1 was how do you find the slope of a tangent line, which is called a derivative, right? And once you've learned how to differentiate, the second main thing was, okay, now you know how to differentiate, use it. And you used it for finding equations of tangent lines and velocities and acceleration and finding the optimal value for a box without a lid or whatever. And Calc 2 was how do you find an area under a curve, which became integration. And it was techniques on how to integrate complicated functions, like integration by parts and x subs and whatever. And then lastly, well, once you know how to integrate, what can you use it for? So we're coming to Calc 3 now. So what's Calc 3? Do you think there's going to be some other thing, right? Differentiation, integration, and then the other thing, and we're going to do the same? Yep. And Calc 3 has a kind of unusual kind of background. It's really all those cool stuff that we couldn't figure out where else to put it. So you're going to find that a lot of the things are not connected to each other. The first thing we're going to do is chapter 11, which is sequences and series. And that's a major one. And most people who've done Calc 3 will tell you it's the hardest, in their opinion. And it's about Well, let's just call it sequences and series right now. And then after all that, can you see, you then hit chapter 10. And chapter 10 is only about parametric curves, which is very easy, in my opinion. Then you move on to chapter 12, which starts in week 6 roughly. And chapter 12 is all about three-dimensional coordinate system. You know how you have got the X and Y Cartesian? Let's do X, Y, and Z. So now you have three-dimensional space. And how does that work? And we're going to be looking in particular about vectors in 3D, dot products and cross products in 3D. And what does the equation of a line and the equation of a flat piece of paper called a plane look like? And that's chapter 12. Chloe, come out of there. Come on. Come on. Chloe, come here. Come on. Excuse me while I fight with my little dog. She found a way to get under the table. And I don't like her there because there's tables. She gets everywhere. Right. Phew. Sorry about that. She has a habit of biting things, and electric cables and little dog's teeth don't go well together. So I'm kind of worried. Where was I? Oh, okay, so that's chapter 12, all about 3D stuff and vectors, chapter 13, I should say. Then we move on to calculus, three-dimensional functions. Essentially, how do you differentiate curves in 3D? And what does it mean to find the derivative of a curve in 3D? How do you integrate things in 3D? And what does it look like and how do you do it? And finally, partial derivatives. And chapter 14, partial derivatives, is actually where Calc 4 starts. So that's the overlap. And what's partial derivatives? It's differentiating functions in 2, 3, or 43 variables. And they're called partial derivatives when you have a function with lots of variables in them. And you can integrate them as well. That's pretty much. What you won't find, except in maybe the vector stuff, is an awful lot of applications. So there's not going to be, you remember pulling buckets up cliffs and the work done in doing this, or velocities, a little bit of velocity stuff, but not much. So it's going to be a lot of theory and not so much applications. That's just the way this works. And that's what Calc 3 is going to look like. So when you look at it, sequences and series has got pretty much nothing to do with parametric curves. And vectors in 3D doesn't really have that much to do with partial differentiations, right? So there's lots of different things pretty much on their own. So don't try and make too many cross connections because you won't find them. And there's all the good stuff after that. Any questions up to this point? Right, I mean, you can go and read it if you want, you know, oh, what was that about? So here is how your grading is going to work here. 6 criteria. Participation is 10%. And all you're going to do is say your last name in chat and I'll collect it. So it's only 10% of your grade now. Homework assignments, 25, as usual. Those online class tests, remember the one that, you know, during Saturday, Sunday, the weekend, you get 90 minutes. When you click on them, you get 90 minutes to do them, that's the end. And they're going to be worth 20% of your grade. So there's a lot of points in there.
For the tests, I'm guessing that we won't have like 5 attempts to get each question right, like we do on the homework.
You will, but you won't know which one's right. So if you change your mind, I've gave you 5 shots, right? So whenever you'll type in the answer and submit, it's just not going to tell you if you're right or wrong.
Okay, sounds good. Thank you.
Okay. 8 out of the 10 are going to get used. So if you bomb 2 of them, right? If you have really bad couple of tests, it won't matter because I'll only use the best 8. So that's it. The midterm is going to be very like the final. You remember when you turn up and there's a PDF? So it's just going to be, it's not going to be in WebAssign the midterm. It's just going to be during a class day like this, right? And you're going to be doing it and you're going to upload your working, and that's how I will grade you. And the final's pretty much the same as well. Extra credit is basically, the most extra credit you can get is 2.5%. So there's a max to it. For instance, you get 0.25% for every week you don't ask for an extension. And then there'll be other things from time to time. And someone's asking, where's quaternions? Quaternions are left with Professor Hamilton where they deserve to be. That's a comment from someone. So we don't do quaternions. Quite interesting things, quaternions. They're the extension of complex numbers into 4 dimensions. Okay, there's the details of the homework in the midterm and the final. Oh, our final is, where is our final? It was on Tuesday the 15th. That last week, Monday is a revise for final, right? Nothing new by then. And then in your case, on the Tuesday, you get the final exam. Are we good?
I have a quick question.
Sure.
So on those weekly tests, you said that they open Saturday morning and they close that same Sunday night?
Yeah.
Okay, cool.
What that means is you can take the test anytime you like. But when you take it, you've got 90 minutes. Once you hit on it, it's got a clock timer. It ticks down. So don't hit it until you're ready to do it. And the reason why it won't even appear until Saturday is that accidentally some people, if I put it, you know, in the normal Monday to Friday stuff that you see, you might hit it by mistake and then you're, I've started the test and I didn't mean to. At least if I wait until the weekend, the chances are that that's less likely. Anything else? We are good.
I have a question about the midterm.
Sure.
So are we gonna have an extra amount of time like we did for our previous finals?
I'm trying to figure out how to make that work. I haven't really figured it out because it's a little bit hard because we could just start an hour early, which isn't a big deal, but you might have an 8 o'clock class. That's why it's a problem. So I'm not quite sure how that's going to work. I'm still working on that in my thought process. But my goal is to try and give you some extra time, but it's how to make it work so it doesn't interfere with your other classes. That's something that I'm thinking about. Let's do a quick, I think you're all here. Does anybody here have a problem with 8 o'clock? Do you have an 8 o'clock class? You do, David? You have my 8 o'clock class, don't you?
Yep.
Yeah. Anybody apart from David? We can figure out some special for you anyway, David, so it doesn't matter. One person I can handle. It's when 20 of you, it's a bit difficult. I can't see anything. I'm going to put it on full screen here in case I've got it. Do you know that little thumbs down thing? You can do that if it's a problem. I can't see any thumbs down, which is really good news.
I won't be able to make it on a few of the days because I have to be in Oregon. So I won't be here around 8 o'clock because that's when I'm going to be giving a presentation.
You're going to be in Oregon during the midterm because that's the only time that this matters.
I think so.
Then you're going to have to contact me and tell me about it, and we'll have to figure something else out for you. David, I know about, and Peyton, if you're the only other one, we can work around it. So it looks like I've got my answer. The answer is that we'll probably start at 8 then, and that gives you 2 hours to do it. It won't be as big as the final, so you should have plenty of time to do it. Yeah, that works for me. Find out a way of making this happen. Right, we got any other questions before we kind of get stuck into the good stuff?
Yeah.
Right. Yes.
Why did you decide to change the how the class is done versus last semester? Just curious.
My thought process behind it was I was trying to figure out ways to, what's the word? to organize your life a little bit more, because if students have a fixed time to do things, it tends to work better when you have deadlines, doesn't it? So I'm just trying to force you to prepare for tests by having little quizzes. Because if you do those tests, you're going to prepare for them. I'm assuming you want to get a good grade. So when the midterm comes, you're already prepared. Otherwise, you got to do 5 weeks in 3 days, and you're not as prepared as you would be. But if I kind of force you to be prepared, I am helping you, right? That's kind of my first process. And the second is I wanted to adjust the percentages, because I, turning up in class, or at least putting your name down, isn't really the same thing as participating as in homework. So I wanted to find a way. And I think the quizzes are kind of homework, because that's what they're going to be. They're just going to be homework questions put in a slightly different format.
On the weekly tests,
Mm-hmm.
are we gonna have a fixed amount of questions per test?
Oh, I doubt it. And some questions take a lot of, take a lot of time, and other questions are very quick. So, it depends on the topic. Sequences tend to be pretty quick questions. Series tend to be quite long questions. So you'll probably get a lot of questions in the first one because there's a lot of sequence stuff in it, and fewer questions in later ones because they're in sequences. Right. Any more questions?
Yeah, is it going to be black and white, like you either get it right or wrong?
That is the problem, yes. So when you're doing the quizzes, the tests, test 1 to test 10, I should call them tests, not quizzes. Yeah, so make sure that you are up to the best of your ability correct. So yeah, but that's true about homework as well. But you won't know you're wrong. When you do homework, it puts a little check mark when you get it right. You'll just get 5 shots because you can change your mind, but you won't know which one it is. So you have to be more careful. But 2 out of the 10 get thrown out. So if you have really bad time, that should be it. Math is a little bit easier than that because you either are right or wrong in many questions in math, aren't you? There's not really a grey area that you might get in some of the other subjects. So hopefully you'll be fine. On the other hand, the midterm and the final, it's your working that's important, and therefore you get partial credit. And those are worth a lot more percentage points as well.
One last quick question.
Mm-hmm.
What about on these tests on Saturday when Web of Science being really picky?
I will try and be unpicky for you then. So if it gives you a question and you've written the right answer, but maybe not in the form that it wants, we've had that situation before. I know what the right answer is, so I'll give you the points anyway. So it's not that I'm just going to let it give you a score. I will go through everybody's to make sure, that it's being fair to you, right, when you do something. I'm trying to think of the top of my head. Do you know how the answer might be a half X? And you call it X over 2, and for some reason it didn't like X over 2 and called it wrong, but you really were right. That kind of thing I can fix, right? Or if you meant to have a comma between 3 answers and you didn't, and it says you're wrong because you forgot the comma, I can see that. I'll fix it, right? So hopefully I'll catch all the obvious weird stuff. Are we good? Right, I am now going to try and move this window. Gotcha. And we are now going to be getting started. A lot of the stuff I've got is online. If you go to Canvas, there is a whole load of videos by other people, so you can see different ways of doing this stuff. I think that's very helpful because I don't always come up with the best way of doing things. There's notes there, there's homework help there, and of course, this lesson and all the others will be there eventually as well. So let's get the show on the road. Gotcha. Right. Now, what you're looking at right now is our first topic, 11.1, from chapter 11, Sequences and Series. Well, a sequence is just basically an ordered list of numbers. And we tell people how to calculate the terms, that's what we call individual numbers in that list, of a sequence in 3 major ways. They can tell you a formula. They can write it down using essentially a set notation that looks kind of clunky, a bit like this. Me personally, I like that format. I don't like this, but you know, it happens in questions. And this, and this is called a recurrence relation. So sequences tend to be pretty easy to do. I do have a video that tells you how you can actually let your calculator do this for you, but very often it's easy to do by hand. So it's up to you how you want to do it. Let's suppose I have a sequence and it's described as n squared plus n. Now, A1 would be 1 squared plus 1, which is 2. And A2 would be 2 squared plus 2, which is 6. And A3 would be 3 squared plus 3, which I believe is 12. And you will sometimes see sequences written down like this. Kind of like a little list, a little set. Would you agree that that's a pretty straightforward way of telling people what a sequence looks like and how to calculate its terms? Plus, it has a very, very strong advantage. If I only wanted to know what the 100th number in the list, don't I just do 100 squared plus 100, which is 10,100. It's very easy when a sequence is described by a formula like this. And you can use your calculator to do those. Now, that would be the first one. Now, the second one is essentially the same thing. It's just the way it's written. So you might be given this guy, little set notation, little curly brackets, and n equals 2, in this case, n equals infinity. Right, back to this one. When you write down a sequence like this, it's assumed that you start with n equals 1. Doesn't it make sense that n equals 1 would be the first term in a sequence? For some reason, you may not want to know the first term. Can you see here that you actually start at the second term? N equals 2. So if you plug n equals 2 into here, you get 3 squared plus 2, that's 11. That's what you get when you use n equals 2. If you plug in the next number, which is 3, you get 3 cubed plus 3, which I believe is 30. This one probably won't work, but I'll go for it. 81 plus 1, okay, 85. And if you wanted to write this sequence down, it would be 11, 30, and 85. ... Are you comfortable that this notation and that notation are essentially just different ways of telling you how to get a term? If I wanted to know n is 1,000,000, I'm not doing it, but couldn't I do 3 to the power of 1,000,000 plus 1,000,000 and get the answer, theoretically at least? And then we have recursive relation. That's not really the same thing. It is a formula, but a funny kind of formula. Because it doesn't tell you, like these two guys, how you get the 10th one by just plugging n as 10, or how you get the 4th one, right? Just plug n equals 4. It tells you how to get the next number in the sequence in terms of the previous number in that sequence, take away 1. So, show you how it works. You're told this guy, it's very often called the seed value. So A1 is 3. Now, if you want to get A2, What this formula says is A2 is twice A1 take away 3. It's twice 3 take away 1, which I believe is 5. Do you follow that? How that recursive relation allows me to get the next term. Right. If I wanted to find the third term, wouldn't it be twice the previous one take away 1? Twice 5 take away 1, which is 9. Does that make sense? Are we good? Right. Any volunteers? What would A4 look like?
Would it be 17?
Oh, maybe. Can you tell me the formula that you would use to do it? I believe you're right.
You'd go 2A3 minus 1. So 2 times 9 minus 1.
And if you wanted to, couldn't you go 5, 9, 17, and so on? Would you agree that the recursive relation is a little bit clunkier than these two, right? Because you don't have a straightforward formula. Don't you have a formula that uses numbers that you had to calculate first? For instance, if I wanted you to find A100 using this recurrence relationship, wouldn't the only real practical way of doing this would be to find A1, A2, A3, all the way up to A99, and then get the guy I wanted? Can you see that this does not lend itself to finding high value terms, right? A100, A 1,000,000, right? In fact, if I gave you the job of finding A 1,000,000, wouldn't you say I ain't doing it? Right? That would be my attitude. I ain't doing that because I know what I'd need to do that, right? You'd probably set it up in some computer program, wouldn't you, and let it do it for you, right? But human beings, nah. If I said A 1,000,000 here, wouldn't it just be 1,000,000 squared plus 1,000,000? You could do it in a calculator very quickly. So this relationship is a little bit clunkier. It also has an even stranger version of it. What sequence do you think this recursive relationship is going to generate? Any ideas what this would end up looking like if and I'm going to do it in a few minutes, what the next few terms? Say it again.
The Fibonacci sequence?
It is. It's going to generate the Fibonacci sequence. In fact, that's how the Fibonacci sequence was described in mathematical books when the guy Fibonacci decided to create it. So let's show you how it works. I know A1 and A2, so I want to find A3. Right, so you think of, well, A3 then, if that's 3, won't this guy be 1 less? And won't this guy be 1 less than that guy? Does that make sense? If this is 3, that'll be 2, and that'll be 1, right? Now, I know that this guy is 1. I know this guy is 1, so there's the answer, 2. Now, if I wanted to get A4, I would do A3 add A2, which would be 2 add 1, which would get me 3. Do one more, I think. If I wanted A5, it would be A4 plus A3. That would be 3 plus 2, which is 5. And now if I write them down, 1, 1, 2, 3, 5. Can you see the beginnings of Fibonacci sequence? If you knew what Fibonacci sequence was, don't you basically add those two terms, those two, to get the next one, and then those two to get the next one, and those two to get the next one, and so on. Any questions? Are we comfortable with the three major ways in which a sequence can be described and so that you can calculate its values? So what we're going to look at now is finding the limit of the sequence. Now, to do that, let's find out what we're talking about. We're actually saying find that, which means that you are going to, what's she eating now? God, you all know how easy it is for me to distract myself. Can you imagine how easy it is when I've got a 11-week-old puppy that you don't know what she's up to? Bailey, he's sleeping away here because he knows his job. When I teach, he just falls asleep. That's not your job. When I talk, you make me stay awake, but his job is to fall asleep. So back to this guy. We are going to use techniques from limits. What kind of techniques am I talking about? Can't we talk about brute force? Just plug in infinity and see what you get, right? Can we use L'Hopital? Isn't that a very common technique, right? Oh, so let's show you some examples of a limit. Suppose I tell you that an is 1 over n plus e to the power of 1 over n. Now, if that was my sequence, I mean, it would be written down originally like that, right? Well, wouldn't this one lend itself just to brute force? Right. So 1 over infinity plus e to the power of 1 over infinity. Now, 1 over infinity is 0, isn't it, as a limit? And isn't 1 over infinity 0, so that's e to the 0. So what do I get? E plus 1. Would you agree that the limit to that one is just 1? Does that seem? Yeah, suppose I asked you. So that one would be brute force, right? That's a technique that we've used. Suppose I asked you for the limit of this particular one. What technique do you think I might use this time? Because if I try brute force, I get indeterminate form, don't I? I get infinity on the top over infinity in the bottom, which really isn't much use to me. So what technique would I use to find this fella?
Isn't it like the L hospital something?
It is the L hospital guy, correct. And what that does is it says that you essentially differentiate them. So if you differentiate this guy, you don't get anything. If you differentiate this guy, you get that. Unfortunately, isn't it still indeterminate forms, right? When you plug in infinity, it's still infinity over infinity. But aren't you allowed to keep doing L'Hopital till you get an answer? So I'll just do it one more time. And this time it becomes the limit as n tends to infinity of e to the n over 2. But this time I can plug in and oh God, what you doing? Where she's found. I'm going to put you in your cage, young lady. Where are you? Yes, you. She can't help it, she's a puppy. Okay, e infinity over 2, isn't the answer infinity, right? So you could say that this limit is infinite. What other term can you also use when an answer is something like infinity as we have here?
That it diverges.
Yeah, so you could just say diverges, right? Now, suppose I gave you this fella. Get out of here. That's it. Come here. She got back under the thing. I know what's going to happen to you, young lady. You're going in your cage for the time being. There you go. I think you might hear some crying for a few moments and then she'll be fine. Oh, okay. God, where's my brain going? Oh, this fella. Any suggestions how to tackle that one? How about that guy? Last chance. Okay. Let's switch the sign and the limit process. You are allowed to do this. It's okay mathematical, right? Would you agree, forget about the sign for a minute, would you agree that this limit is pretty straightforward? Couldn't I do that by L'Hopital? In which case I get the answer 2/4, which is a half. Couldn't I do it by divide top and bottom by n squared if you wanted to go that route and still get the answer a half? So what do I get? I get the sign of a half. Are we comfortable about limit strategies, right? Methods to find limits, right? Now, almost all your questions are going to be where the formula is clearly involved. But just to show you, that guy, and let's say A1 is 4, just for argument's sake. You might think, how could I possibly find the limit as n tends to infinity of that guy? This is, I don't think any one of you have seen this before. It's a sneaky cheat, but mathematicians like sneaky cheats. What we do is we say the limit as n tends to infinity of this should equal the limit as n tends to infinity of that side. Would you agree if these two are equal, shouldn't their limits be equal? Would that be a reasonable assumption to make? And here's the sneaky part. I do not know what the answer to this limit is, but let's call it L. Would you agree the limit as n tends to infinity of an plus 1 is basically what happens to the sequence when it goes infinite? And we're calling it L. But wait a minute, isn't this guy also L? And minus 2 is minus 2. Are you still with me? Does that logically make sense that you could do that? Right. What's the difference between A in a million and A a million and 1? Would you agree they're both going to the same final answer, right? Their limits are going to be the same number. And I'm calling this L. What do you think I do now? What do I do now? It's okay to be wrong, but you know, chuck some out.
Do you just get to call it infinite?
Oh, I wouldn't do that yet. It might be, but not in this case. L is just a number, or maybe infinite, but let's say it's a number. equals 0.3L take away 2. I want to find out what L is. So what should I do next?
You subtract 0.3L from both sides.
So mathematically, shouldn't that be true? What should I do next?
Divide by 0.7.
Right, not the nicest answer in the world. Can you trust me? It's -27ths. Can you see that you can generate limits even for recurrence relationships if they exist? So this ends up homing in on roughly -27ths. So if you did A1, plugged it in A2, plugged it in A3, kept on going, you would see a sequence of values that would slowly but surely end up being roughly -2 6/7, right? So far, so good. Right. I think for the last few minutes, what you can do while I'm getting myself organized is, for attendance purposes, just say your last name. So Mia, you're just going to say Spandler in chat, and that'll give me a few moments to look over and get set on the homework. So you all saying in chat, all that good stuff. 24 looks good. I think I should be ready now. Now let's show you what it looks like in well, the first question is basically what is the sequence? Right, here's a guy. List the first 5 terms of this sequence. So if I wanted to, for instance, that guy there would be 5 cubed, take away 4, which is 121. Here's one of the funny little guys. Actually, isn't that the one I did a few minutes ago? So I guess I forgot, but that's fine. Okay, this -1 to the n-1 over n squared. Got to be careful with that. When you find A1, that means n is 1. Okay, so let's see what we get. -1 to the power of 0 over 1 squared. Okay, what number is -1 to the power of 0? And it is a number.
1.
It's 1. Isn't 2 to the power of 0, 1, 50 to the power of 0, 1, -20 to the power of 0, 1. So 1 over 1 basically makes that guy 1. On the other hand, if you wanted A2, -1 to the power of 1, which is what -1 over 2 squared, is -1/4. And I'm not getting the same thing that you've got, but you know the little palette guy? Wouldn't you write down -1/4 and you make it look like a fraction? If there is no to 4 decimal places thing going on here, will you try and give exact values? And so it's okay for your answers to be sine 2, sine 4, sine 6, right? You don't need to turn them into anything if it doesn't mention to 3 decimal places, right? So exact values, unless otherwise stated. And there's a cosine one. That one's quite interesting. Does anybody know what the answer to this is going to look like? What kind of sequence do you get from the cosine of n times pi?
1 and -1.
Well, if you plug in 1, you get the cosine of pi, and we know that's -1. And then you get 2 pi. And then you get that one. And then you get that one. You nailed it. Couldn't I generate that exact same sequence by using this formula? Oops. Does it not generate the same terms? I've seen questions where they stick that guy and then they put an n squared over n. You know, they do that as part of it. And what you fail to realize that that guy, although it looks like it's something to do with a cosine, isn't just an alternating one. And so you can sometimes get thrown, especially if you're trying to do a L'Hopital on it, which wouldn't be good. And I think this is going to be my last thing. Has anybody seen the factorial guy before? That exclamation mark. Anybody seen that guy? Okay, then let's show you as our last thing for today. If you were being asked to generate the first 5 terms of this fella, you have to know how to calculate as a number things like 3 factorial, 5 factorial. 3 factorial is 1 times 2 times 3. It's a number 6. 5 factorial is 1 times 2 times 3 times 4 times 5. Oh, I should have picked a smaller number, shouldn't I? 120. Let's do some silly ones. 2 factorial is just 1 times 2, which is the number 2. What would 1 factorial be? I think you mouthed it. Matthew, do you want to mouth it again? We'll see if you're right. You got it. It's just 1 on its own, isn't it? Yeah. Here is one that you'll probably be amazed at and also don't believe me, but it's still true. And it's not what I think some of you think it's going to be. What do you think 0 factorial is?
Is it going to be 1 because it's some like messed up sequence where n always starts at 1 because of how the factorial sequence is?
Not sure your explanation is correct, but your answer is. It's not connected to, but it's an analogy. Isn't 2 to the 0 1, right? You know, powers of 0 can generate 1. Factorial with a 0 in front of it. You're just going to have to trust me on this one. It is equal to 1. And if you don't want to trust me, which you shouldn't really, because I do make mistakes, but not this time, is you're going to have to look up a function called the gamma function. So if you want to find about it, the gamma function is a generalized version of the factorial function. And what the gamma function does is that it allows us to calculate 0 factorial. And the gamma function is described in terms of a special integral. And as long as the n is a whole number, you get factorials. What the gamma function, and it looks like a little hangman symbol, is that you can actually find the gamma function for any number. So when it's whole numbers like 3 and 5 and 2, you get the factorial guy. But when it's things like a half, I think gamma of a half is the square root of pi. Just tell you that off the top of your head. That's the guy you're going to look. But for the rest of you, aren't you just going to trust me because I told you it is? So if you ever see a 0 factorial, it is on your calculator, especially if you're having to deal with maybe larger numbers. So here we go. Switch this on. Let's find 5 factorial. So there's 5. I believe it's a math button. Over to probability and down to choice 4. Do you see it's a little exclamation mark? 5 factorial. 120. Yes, Matthew.
Couldn't the factorials be represented as a what's it called? Recursive sequence where it just multiplies it by n every time. And then that would also explain the 0 factorial being 1 because 1 times 1 would be 1. And that would explain.
Very interesting. So if I'm picking up correctly, you're saying that a to the n is basically what? The previous answer times the next number.
Yes.
Yes, you can write the factorial function in terms of recursive relation. If you're into programming, isn't that actually a very useful way of generalizing? Can't you just put it out? Well, I would call it a for loop. Who knows what you call them today, right? You could put it into a for loop and calculate it. Yeah. This is not a formal proof. I'm going to try 0 factorial. And I want to see the answer 1. And if I don't, then can you pretend you're looking at 1? 0 math over to probability, choice number 4. Oh, isn't that nice? Agreed? 0 factorial is 1. And bye-bye. I'll see you all tomorrow.